Hello, welcome to our Microsens Webinar. In this presentation, I would like to introduce you a new approach for building automation as an alternative solution for the conventional way of doing building automation today. But before we do this, or before that happens, I will start with a short introduction to show you a typical sample of conventional building automation today, based on an automated ventilating unit, which is very common in smart buildings. A usually kind of installation look like this. We have here the ventilating unit, shown on the left side. We have the control cabinet, which is providing the automation functionality, usually by a PLC or a DDC controller, and both are connected over cabling, conventional cabling mounted in cable trails. So to analyze the structure of our sample ventilating unit, we can transfer it into a layer model for conventional automation system, which is looking like this. So you see here the different layers. We will start from the bottom one, which is the field and I/O layer. In this layer, we will find all the sensors, actuators, and bus systems for collecting all the physical information directly from the field. In this area, we will find temperature sensor, pressure sensors, valve actuators, and so on, and also the mentioned bus systems like KNX, LON, Modbus, and so on. All the sensors and actuators are connected by wire or by bus system directly to the automation layer, where the PLCs or the DDC controller mentioned before are located, mostly mounted in cabinets. And this layer is connected over the network with the management layer. Additionally, the network layer is provided the complete network infrastructure for building automation system, which allows once to connect and to network all the PLCs, but also to provide the data transfer from the automation layer to the management layer, where is the common BMS platform. On the top, we will see the layer which is responsible for cloud services, but this is still the exception today. Actually, the majority of conventional BMS systems provide none or less cloud services or functionality. But nevertheless, these features and functions will be the technology of tomorrow or the future technology, and it has still started today with implementations on this layer. So, what are the typical characteristics? So first is mentioned that we have conceptually the same approach as 25 years ago. What does it mean? This means that 25 years ago was the first change of in the area of automation, because 25 years ago we start with the change from the analog technology to the first programmable units. That was the area from the DDC controller. And in this period, unit had performance or use a microcontroller which has maybe 8-bit resolution, and the performance was, according to today, very low. Today we run 64-bit controller, and this is, I think, the main change, that the automation layer becomes more performant, but the structure, I mentioned this in the picture before, cabinets, conventional cabling and so on, has remained the same. Second characteristic is building management platforms for building automation are primarily based on BACnet. BACnet is a standard for building automation. BACnet stands for Building Automation Control Network, and is very common in buildings, for building in the building automation area. Other typical characteristic of conventional building automation is the parallel use of many different protocols and systems like KNX, LON, BACnet, Modbus, DALI, or SMI. I defined the name Babylonian protocol diversity because this description shows very or stands very fine for the parallel use of many languages in a building automation system. So another characteristic is that building automation today needs to run on their own network infrastructure. So why this happens is mentioned in the next characteristic, that there's a weak or no impact on network security and redundancy mechanism, so that the IT section is not willing to include this weak in security networks in their own network infrastructure. What is also typical is that we have conventional discrete sensors and actuators on the I/O level, and we will see that there is no IP-based sensors and actuators available on market. All this lead to the situation that we have a high amount of mechanical installation for control cabinets, cabling, cable trays, and so on. And if we see on this topic, we can understand why, because of the high amount of mechanical installation, we have also extensive planning and engineering. So, facing all of these facts and keeping in mind that Microsens is a manufacturer of structured network infrastructure components, we started to develop a real alternative approach for building automation based on network and IT standards. And the result is this. We call it NESDA. NESDA is standing for Network Embedded Software Defined Automation, and is a new approach for doing automation by doing this out of the network. So let's have a before we go to the next or before I show you more detailed the approach, let's have shortly a look how networks are used today in a conventional building automation system. So what we recognize is that we have in general many several subsystems in a building which run mostly on their own network or data infrastructure. And if we see this concept and think about what we talked before, then the approach from Microsens, or the way how Microsens thinks about building automation for today, is presented here. Microsens is thinking in, we have one big network which provides the data and IT infrastructure for all the several subsystems in a building. So how does it look in a detail? So we have here, for example, a small simplified example from a network. The picture in the middle, the core network is representing the completely core network in the building. On this is connected on the top the building management layer, and on the bottom side we have connected switches which are representing distributed automation devices which are running the several automation functionality directly out of the network. So typically for this structure is that we have a distributed architecture which is PLC, where the automation is PLC based, and we have a central monitoring providing on the management layer. We have an easy installation. Why easy? Because we can do this installation controller after controller, room by room, during a running system. And by doing this, we have also a high reliability, because if a failure happens, the failure has only an impact to the local unit, which creates the error or the failure. the integration in a we can integrate the devices on a central control on demand. This means that we have the possibility to do the building automation step by step in the building. So, but now I would like to come back to the layer model from before, and the big question is, what is difference, or how the differences to the Microsens concept or approach are defined, and where are they located? So if we come back to this layer model we had before, used before for the description of the conventional building automation, we see here again we have a field I/O layer, which sensors, actuators, automation layer, network automation layer, management layer, and cloud services. So first step what we have done is we developed a device which is called Smart Air Controller, and this Smart Air Controller enables us to use conventional devices and bring them directly into the network, from the field into the network. So we have done the same for lighting by doing connecting the lighting functionalities directly to the network. So what you can see here, we jump over a layer, the automation layer, and this automation layer, which was in the past responsible for doing the automation, is in our case not really necessary, because we have implemented into the network layer software-defined PLC or soft PLC, which is taking all or covering all the tasks for automation which in the past were installed in the automation layer. This means in the cabinets which were located in the automation layer. By doing this, the traditional automation technology with PLC in the control cabinet is replaced by software-defined control on the switch, and we have we jump directly from the field into the network and provide automation out of the network. The top layers, management layer and cloud services, are still remaining the same like before. They cover the same functionalities. The main difference is that the automation layer has been virtualized by transferring his functionality into the network layer. This means into the switches. How does it look like? So, and what is the nice thing, by the way, we can provide from the field to the top management layer, to the cloud level, one IP infrastructure, which makes the handling for the IT guys much more easier. So let's have a look how the system is consisting and how it looks like. So we will start again by our PLM. We use the PLM in this example, our smart engine. On this smart engine we have connected over a smart lighting controller an LED panel, and the smart lighting controller is connected via PoE connection over a patch cable directly to the switch. So we run the lighting over PoE on this case, and the functionality, power supply and functionality, this means data, are provided over the switch. So we use for collecting the different sensor signals from the room, like switch buttons, climate units, blind controls and so on. We use a wireless connection via an ocean, and for all devices which are not able to be transferred via an ocean, we have developed a smart air controller. I mentioned this before, and he covered the rest of the conventional sensors and actuators are located inside the room. So inside the PLM we have located the soft PLC, which is called Micro RTS, or a Smart Director app, which is a small script-based automation platform for covering the automation functionality. The programming of the soft PLC is doing by Microsens. Microsens is our engineering platform, which is IC 61131.3 conform. This means it's all the industrial standards for programming of PLCs. So, and it makes it very easy for an automation guy who knows how industrial PLCs get programmed to use our system. So, with Microsens, we write the program, make the compile, and make parallel also the download to the engine, where the micro RTS or the soft PLC is running the programmed application from Microsens. So for the visualization, we have an embedded web server inside, and we can do a local web server. We can run this local web server as local user interface with small graphics, for example, to run blinds, to switch lights, to set temperature values, and so on, as local user interface. We can get access to this web server over standard smartphone, tablet, PC. So what you see here is, in general, the main idea behind our system. And if we want to come back to the characteristics, we have a uniform data infrastructure from the field to the management layer. This means that we run only Ethernet from bottom to the top. We have high IT security level through secure open IT standards and protocols. We have encryption, HTTPS, SNMP v3. The unification of communication protocols and interfaces by using IT standards, like here, is given. So we have a structured cabling based on CAT and fiber optic standards from the field to the management level. Reduction of the hardware components, control cabinets, cabling and cable trays and routes. I will come to this some pages later. Then you will see how easy and how standardized this part is done if you use NESDA. Also very important is that by the using of our concept, the reduction of file loads and associated measures is given, and we have a simplification of planning and execution, like mentioned before. And finally, the integration of smart lighting. We have, additionally to the automation functionality, also the integration of lighting over the network by using the PoE. So, how does it look like? Here we have a sample for a smart lighting concept. You see we have here a core network which is connected with the local smart engine. This is the PoE power supply, and we have here our smart light controller, which is a sensor, and the LEDs. Until this point we have network. Here's the power supply of each LED, and this is the sensor. With the smart sensor we cover presence detection, temperature and humidity, and also brightness. So this is a typical sample for PoE feeded lighting directly out of the network. Additional to this, we have also a DC lighting concept based on the central smart light controller. The big advantage of the central smart light controller is we use the standard CAT cabling for networking, also for the connection of the lights. We have here AJ45 connectors to connect over standard patch cable directly LEDs. And we have also AJ45 connectors for connect the sensors, which are responsible for catching motion, brightness, temperature and humidity into the building. So here you have a look how our hardware is looking like. On top we have the central smart light controller, like I before described. And you see you have here RG45 connectors where we can connect the several LED lamps. We have here the connectors for the CAN bus, which is also using the RG45 and Cat5 cabling. And on the top we have here the two uplinks for the connection to the network. This device provides here directly DC power outputs, which are using only the Cat cable infrastructure for the connection or the connectivity. In the line here at this point we have the smart light controller, which is our device we use for lighting over PoE. We have here a standard PoE input and data port, and this is the connection port for the smart sensor. Then we have here our smart I/O controller for digital and analog inputs. We have developed both devices because on the smart I/O controller digital we use mainly digital inputs and outputs, and the smart I/O analog controller we have in the focus for analog controls applications. So on the bottom line we see our smart sensor. This is the conventional one, and this is the smart sensor for the CAN bus version, which is used with the central smart light controller on the top. The conventional smart sensor is used for the SLC approach. And on the right side we have the PLM and the micro switch. These are standard switches. This on top, the PLM is the industrial switch, and this is the micro switch we use for our room applications as platform for the application. At this point I have to mention that in all our platforms, this means the sensor smart light controller, the PLM and the micro switch, we can install our PLC automation platform for doing all the applications we need for raw automation and building automation. So on the next page we see how it looks like in real if you have the smart light controller in action. Here's the smart light controller with a naked LED here, which is without a driver. It's only the LED device connected by two wires on the output of the smart light controller. The smart I/O sensor is connected over this small cable on the smart sensor port, and this is the data and PoE port coming directly from the switch. So next example or best practice sample, I mentioned before that we reduced the usage of hardware and cabinets. Here we see here we have a standardized cabinet with pre-cabled devices. We see here the power supply. We see a PLM with his extension devices pre-wired on RG45 connectors. On the left side we have some fuses which provide maybe 230 volt circuits for several needs. And this completely device is called smart distribution box and could be seen as a multi-purpose cabinet. What I will mention or what I will say with this we will see in the next picture. So we have again here, for example, our ventilating device. And if you remember back, this ventilating device was connected in the first page over a cable tray and conventional cabling to a conventional cabinet. In our approach, we don't do this like this, but we install the smart I/O, or not the smart I/O, the smart distribution box, sorry, directly on the device, like here. we use some smart I/O controller, which are also installed locally on the HVAC device. In our example or sample here is a ventilating unit, and the programming or the functionality is defined only over software inside the switch, in our case the PLM. So this means that we collect all the local data like sensors, actuators and so on over the smart I/O controller, bring them directly, connect them over a PoE port to the PLM, and the program and the functionality of this ventilating unit, for example, is defined by software which is running inside the switch. On top we have the management layer or management level, which is directly connected with an uplink to the PLM. So you see we run here a switch locally on the ventilating device or unit, connected we are uplink to the management layer and doing the automation by running a program on the local installed soft PLC. So you see, this is an example how we eliminate the cabinet, the conventional cabinet, for running the automation for this ventilating device by using this smart distribution box. And now the simplification of planning of cabinets will shown on the right side of the presentation. We have here a room, an office, which is representing room automation. We use again exactly the same distribution box connected over an uplink to the management layer, and then we connect some smart light controller over PoE for PoE lighting. We cover with the Enotion protocol wireless switches for buttons, devices for climate control like temperature sensors in the room or blind actuators. We are connected by cable and provide also over the micro switch, which is located here with network, and we provide also over PoE a voice over IP for the phones and VLAN activity. So what you can see here is very nice. We have one developed smart distribution box used in two totally different application cases. In one case, this box is a room automation cabinet. In this case, this box is a ventilating unit cabinet. And if you see this picture, you understood that planning of cabinets will be simplified or to the absolutely minimum. So this means we have only to cover the power connections for the ventilating device, which could be covered directly from the power distribution cabinet from the floor, and all the automation functionality is covering by this box. So this means that if I have many of those kind of devices, I don't make a dedicated planning for cabinets for each device, but I use for each device an own smart distribution box, and to do this is quite more easier as instead to make a dedicated planning for cabinets. So this was the description of the system, and make a short summary of what I've mentioned before. The Microsens approach provides highly efficient LED technology. We have a distributed network embedded building automation system. We have the reduction of conventional hardware and their engineering. If we have remember our smart distribution boxes, which save a lot of time for planning, engineering, installation. And finally, all those leads to a standardization of planning processes, or make, for example, standardization of planning process much more easier compared to the conventional approach. On the security level, we can run the high IT security level provided by the own IT administration, and this is something which in the past was not given, because building automation and IT were two independent worlds, and each of them were responsible to cover their administrative and maintenance tasks. So finally, we come to the topic flexibility. Because of the step-by-step installation which the system allows us, and because of the software-based and OpenID industrial standard, we have a lot of time and engineering time savings, so that we can use this time savings also to do the work more flexible and more easier. And finally, the last and most important thing, everything is run over one network for all applications. So this I come to the end of my presentation, and finally I would like to mention that after decades of conventional realization of smart buildings on the building automation market, I think it's time for a new approach to meet the high expectations of customers regarding smart buildings. Microsens decided to take this challenge by presenting a new way of thinking for the realization of smart buildings today and in the future, and doing this by developing of NESDA, the next generation of building automation. Thank you very much for your attention. I hope that I could give you some new ideas and make you curious for the future, what will happen and what we will bring out with, what is coming out with the implementation of the system. So I hope you had fun with the presentation, and we will see you on the next webinar. Bye-bye.